one source, Rockwell Automation and CTI. Doing a presentation and training for the VFDs, MCC, for the 07 PMP 12001 through 12005 reclaimed water headwork system. This is going to be a little bit more in depth than the Tuesday class. We're going to talk about the internals of the VFDs, how soft starters work, answer questions, do's and don'ts. So let's go with the initial introduction of everybody. What's your name?
Justin King.
Hi, good to meet you.
Hello.
Alan Jones,
Hi, Alan.
instrumentation.
John Mellon, Technical Services.
Well, hello. Good morning. What's your experiences on VFDs? You operate them, and so we're going to go through the operations of it. And
I've worked on various VFDs, some Allen Bradley stuff, older model stuff.
okay.
Not down to component level, but as far
Right.
as how they work, I kind of know how they work.
Okay. What do you guys do when you have a major failure on a VFD? Do you try to get in and fix it, or do you call a rep, or?
You know, it depends on what it is. Say, a lot of times it's more overheating. You know,
Okay.
like a fan maybe will go out because
yeah.
it stops cooling all the,
Mhm.
you know, the intricate part, you know, of electronics.
Mhm.
And then we don't go in swapping boards and stuff like that. If it goes out, if there's a board, and if it's a new, we'll call, you know, Allen
Right.
Bradley, hey, come and check because it should still be under warranty.
Right.
You know, but down the line, usually if it goes out and we see that it's a major component failure, we'll most likely just replace it.
Okay. Okay. These drives out here are a little different than other drives you may find in the facility, as these are 18 pulse drives. Do you know it?
Yes, that's a different, the way they send out signals as far as to the motor.
Mm-hmm.
So they, a lot of them are less pulses, so they're not as efficient, you know.
Correct.
So the more pulses, the more efficient, the better control that it has, I guess.
Correct. How do you know what the major components that are different between a regular drive and a 18 pulse drive?
Well, probably the SCRs or something there.
The SCRs are the same.
They're the same? Well, what's different?
The front end has a phase shifting transformer that'll take 3-phase and shift it 3 times, so you end up with 9-phase. That's where you end up
Okay.
getting
Different pulses.
the 9 times 2 top and bottom, and that's how you end up getting the 18 pulse.
Okay.
So if you can kind of imagine, the transformer will take ABC and then shift another one ABC and another one ABC, and we'll show that on the drawings, and I'll kind of explain
Okay.
where to go, because this drive is separated into 2 sections. Actually, the components are 3 sections, and you'll see it when we get out there. One's like a power distribution section, has some controls in it, relays, time delays.
Okay.
Then there's the drive section, which takes the DC through the SCRs and fires it to the motor. And then there's another section that has the phase shifting transformer and the bridge rectifier to create the DC bus. On the 18 pulse, and that DC bus is always above 600 volts. So don't put your fluke on it to see if flukes are only rated at 600.
Correct.
And I burned up a fluke, but not on a drive. And you know, they melt pretty good, and probably the same thing would happen. So you know, if you're wondering if you have voltage on that DC bus, you can monitor it from the face of the drive. You know, that's not a technique, and the meter's not a technique. We'll go through the status indicators on the door, which is going to be good for you, how to run it in manual, bring speed up, take it out of remote, what kind of scada alarms you're going to get. I kind of made a list of the things that I want to go through here on the VFD. We're going to show where all your physical locations are, your components. So when you get to it, you kind of have some sort of familiarity where things are at. We talked about the 18 pulse. We're going to talk about replacement parts. You know, kind of what is available.
Bring any handouts?
I did. So here's, and you You can have that for your copy. And if you're interested, you can have this too.
I'm sure we'll get something like that.
And this is the electrical schematics to the
Yeah.
drive. The drive and the soft starter, controls-wise, are really similar. You know, start, stop, some of the features that we'll see that carry over is the low flow switch, the motor temp, high pressure, and a vibe. But I don't believe there's vibe switches attached out there. The contractors never ran those wires, so I don't think there's vibe. And they're all on time delay relays. So all that logic is
Like
hardwired.
startup and things of that nature.
Yeah,
Right?
and then coming from SCADA, it's all done through relay logic.
Right.
So the systems are really electrically isolated, but there is power in those panels. If you turn off the VFD panel, you'll still find power in there from SCADA panel.
Okay.
Whether it be, you know, it's just a dry contact or a signal, but there still could be 24 or 110 in there.
So then you know that contact's either open or closed.
Right, and you can visually look at the relay. Hey, is CR2 closed? Okay. We'll explain how it connects to SCADA. We'll go through the drawings and kind of, you know, these are the dry contacts, which, you know, it's good for troubleshooting. Because you might see the alarm out there and not here or vice versa. And, well, you know, why does that happen? The do's and don'ts and how this is connected through Ethernet. Because that's, the Ethernet on these devices are really for monitoring. The SCADA controls all the data that you get through the IP doesn't control the drive at all. The drive is controlled through hardwired 4 to 20 and dry contacts. So you could unplug the Ethernet cable while you're in operation. It is set up not to fault. Out of default parameters, if you disconnect the Ethernet cable and it's running, the drive's going to stop, the motor's going to not go. Why did that happen? Oh, somebody unplugged the Ethernet switch. No, we just lost the whole plant. So that we actually disabled those alarms because we're just monitoring, we're not controlling.
So you can't control?
You can,
Okay.
but this wasn't designed that way. So you could send commands through IP, through instructions through RSLogix 5000 and tell the drive and give it a speed command, but this particular installation doesn't have that. It's
Wow.
just monitoring how much volts, how much amps.
So if something happens in the middle of the night, our operators couldn't go online and say, they can probably look at it, can they start it?
They can, yes, you guys can start it, but the way that signal happens is, let's say when you hit start on your SCADA control screen, or if you go out to the HMI out there and you hit start and the PLC and everything says, hey, you know, run the drive, instead of the command going to the drive through Ethernet, it's going through hardware. So it's going through a relay.
So but you still can't say,
Oh, yeah.
right, okay, I got you.
Right.
Through Ethernet it won't control like you're saying, but
Right, it just
they
monitors.
still can give it that command.
Mhm.
They just won't do it through Ethernet, they'll do it through relay logic basically.
In 4 to 20.
4 to 20. Okay.
And then you'll
Okay.
be able to run it that way. And it's a better design system when you do it hardwired.
Okay.
Y-
Less failure.
I was just listening to NPR coming
Possibilities.
in this morning, they were talking about all the hackers trying to get into districts and into power plants, and I don't know, I guess there's a lot of people out there that are, you know, let's see what we can do.
Yeah.
Maybe it's a hobby, maybe it's malicious, you know, I don't know. But
Challenge. People just, they want to have a challenge, they wanted to do something
Yeah.
different.
or prove themselves.
Bored.
But in a hardwired situation, yeah, you could still get into the PLC and control it, but we're hardwired, it's more of a robust system. We could actually disconnect the network and still run the plant, and that's what you want.
You just want to be able to see it, right?
You can see it at the local display.
The levels, you disconnect the Ethernet, they couldn't see it at home though, right?
They could see speed. I think you see speed, and you see that it's running, and you'll see your faults. But you won't get it's running phase A voltage. You won't see its current. You know, and I'm not too sure what they programmed up here. You know, all the advanced type of stuff. You'll see all the general parameters through hardware.
Amperage and stuff like that, you won't be able to see all that.
No, and that's just monitoring.
They don't even see that anyway, really.
And there are power monitors out there.
Yeah, there are.
There are power monitors, and I don't know if you guys are pulling a power monitor data in. I believe you are.
I think so.
I think so too. And then, so that's all on its IP network. If you ever connect into the network, and I did this morning, to upload all the parameters off the drive, so you guys can have a record and then give you the software for connected components, so that if in an event of a drive failure, let's say you have a complete, or a soft starter, something you call it RVSS on the specs, or a soft starter. These are, Rockwell calls it SMC Flex, just the type of class it is. We can go in there through connected components. We can install a new soft starter, go to connected components, and upload that data that we have saved, and it'll be configured exactly as the old one was, and you'll be up in about as fast as you can plug it in and click upload, instead of going through and changing every parameter. So things are evolving in a good way that way.
And you can actually check them that way too. You can see what
You
you
can
have
do a
in
compare.
there.
Mhm.
See what you have. So
Mhm.
if there's something wrong, you see what the parameters are set up the same or whatever.
Correct. So the parameters that I want to install into the doors, as you know, for good system and pass on to you, I'll give me your email address and I'll send it over to you. What these parameters are, it isn't a list of all 1,000 of them, because that would be 25 pages per. You know, it's just a lot. So what it is it's a list of parameters that have been changed from default. So a drive will come in, it'll be default at factory settings, go through this list, just change those ones, and you're up. That's if you don't have the connected components, if you don't plug it with a laptop. With a laptop, we can plug it in, get the Ethernet going, and go. I know that I was given the list of the IP addresses for, and do you guys have connected components or Drive Executive or any of those type of softwares?
I wouldn't know.
Okay.
I wouldn't know.
Okay. I guess one thing to keep in mind when you plug into a network, I don't know if you ever will, or I don't know if you ever will, but make sure that one thing that would really not be good for a plant is to go ahead and like set your laptop to a same IP address that's already existing out there. Because either A, you're going to shut that piece of equipment down, or you're going to hog up the network. It's usually not good. And
Cause a mismatch of some sort. Possibly.
duplicate IPs, and you know the traffic will, it's just not good. So in this one, they put the drives in, let's say like the 10s, the power monitors in the 20s. So I knew at the end of the power monitors there's an open one there. It's just they kind of IT always sets it apart. You know, this group of equipment are the 10 series, 10, 11, 12, 13, 14. That's all we have. We add more, it'd be 15, 16. So I always pick one at the end of the series, because typically it's not being used. Trying to think where to go next, except for going into the drawings.
Okay. See any questions I have? Nope.
Okay. Okay. And yeah, I'm gonna pass this. You can give it back, and
Okay.
you can kind of see where we're going. I'm gonna open this up, and we're gonna go to page 4. Yeah, a couple more. Okay, there we go.
You don't have to record this.
Portion of the VFD soft starters and pad mounted transformer. We have Alan and Justin. Let me give you a walk around of the equipment that we have out here. We'll start with the main. Here's our main feeder. I know you guys are fun. Here's our main feeder, main disconnect. This will shut down your whole plant. This is coming from your transformer that's out here. Surge suppressor, power monitor for your main. We got volts, frequency, current, power, kilowatts, kVAR, power quality. We go through the menus. One thing you can do here, let's say if you hit exit by any chance, see how it says loading? Sometimes people just hit that button and you'll end up with this screen. It's kind of like the panel view configuration screen. This disconnect is just for the PTs for this guy. So this is the base screen. So
I saw that the other day over here.
Right. So what you can do is you can go, well, here's communication. I'll press it. And you can set your IP addresses. See how your IP address is in there? I'm going to go back to main, go file manager, and then scroll down. See it says PM5000M1A. The initial T4T is just a basic application. That's not the one you want to run. You want to run this PM5001A and then just hit run. And then you'll end up back at your program. So that's how you can recover from there. Disconnect switches for all the in-house room. Disconnect switch for pump 1. Disconnect switch for pump 2. Pump 1, VFD 1, pump 1, 12,001 also has another disconnect here, so it has 2. This is where the voltage comes in here. It's kind of distribution and some relays. Absolutely. So then you could work in here safely. Control panel lights. You're familiar with all this kind of stuff? The HOA, our speed. The min speed on these guys are set at 35 hertz, so you're not going to be able to run below 35 even if you turn it down to 0. If you need to run lower than 35, get maintenance. Somebody can change the min speed setting on the HIM. This is the 18 pulse section where we have the transformer and the bridge rectifier in here, kind of like I was showing on the drawings. We can open this up, but we are running, so if we can get authorization to just turn one off, we can get in there and look at it if you so desire. Once again, we have the same power monitor, and it's monitoring this drive.
Why they put a minimum speed for the pot?
For hand control.
Why did they put a minimum? They start at 35%?
It's because of the pumps.
And they at least require 35% for lift?
For lift and for seal water.
Okay.
So I think if you're below 35, it doesn't get enough seal water, it's going to damage the pump. But let's say if you want to just bump it, you could always lower them in speed and just do like for a rotation check. The pumps have a ratchet on it, so they'll only go one way.
Okay.
So if you go to bump it, you're going to see this current go way high. Oh, it's backwards. The only way to switch this is in a parameter. You can switch the direction on a parameter, or you can move phases. These ones, initially, all of these were backwards. ABC, so now they're the other way around. We switched these ones with the parameter because the cables are so big. It's a big job to change phases. These guys on the soft starters, in order to change the phase, we actually move the phases. You can't change phase direction with a soft starter. And I'll explain why. You can't do it through a parameter because it's just 3 SCRs that are firing each leg. There's no DC bus. There's no inverter to the SCR. It's missing. It just has SCRs. Yeah, it is. So how do you switch it? You can't. Same with pump 2002. I'm going to put these right here. Maybe I'm going to talk to Derek. Maybe when they shut down, I'll talk to him afterwards. We'll get these inside the enclosure. Yeah. The same controls. Justin, is there anything you want to go through on here?
No. I've already thinking.
Okay. And then here's our soft starters. So we got number 3, 4, and 5. They're all the same. Just like I was talking about the network, you could unplug the network cable and keep running, but you won't see your data. And it's also all the same. I guess I got to always go over the same safety stuff. Don't work on hot stuff. If you do, have a buddy system, follow your rules. My oh no button, e-stop. There's also e-stops LOS out there in the field. You guys want to get it? You want to get inside one of these?
Probably not.
Okay. How about the drive? You want to get inside the drive?
Yeah.
Okay. Well, we can look at the drawing. We'll look at the drawing and the physical, and we can pretend we have X-ray vision. Let's go out to the transformer real quick. I just want to show you. So just go around and look for discoloration. Open the door on your maintenance checks. Make sure it's got proper oil level. You know, we're making sure we're not looking for heat, oil on the ground, discolored paint.
Is there a lock on
It, you know, it has a, no, there's not a lock on there. Well, I think you need a tool. You need a tool to get in there.
What, like a wrench?
Yeah, or socket. Yeah, I don't have that. Do you?
Yeah, but I don't want to open it.
No, neither do I.
I'm just saying they have a spot for a lock though, right?
They do.
Yeah, they have a spot. So
Right.
We need to talk to those guys and have them
Supply a lock. Okay. And then look at your secondary containment to see if you have any oil down there. If you do, go ahead and shut down. The transformer's gonna go bad. These things have a long lead time, so if you start seeing problems, you might want to get one on order as fast as you can. I definitely wouldn't fill up a warehouse full of spare transformers though. That'd be very expensive. So don't do that. You shouldn't really have any problems with it as long as you keep the oil up and you look for heat.
What's the life expectancy on those? 20 years?
I would guess 20 years.
20 years?
Yeah, as long as somebody doesn't back into it. We don't short out the load. You know, there are things that can cause the transformer to go bad. Weird things, lightning strike. Yeah, you just never know. Do you guys have any questions for the transformer? All right. Well,